if I switch off a fan, does it stop then and there, or it keeps on rotating for a certain amount of time? If we apply brakes, does it stop then and there, or it moves a certain amount of path? Now we know that this is not the case. It keeps on moving for a certain amount of time even after we apply brakes or even after we stop the fan. Now why does this happen? This happens because of a property called as inertia. Now in this example that we have over here, we have a cardboard and we have a coin placed on it, and they both are actually kept on top of a glass, hollow glass. Now as soon as we flick the cardboard, you can see that the coin drops into the glass and does not go along with the cardboard. Now since it was at rest, it wanted to remain at rest, and somebody which is in motion, it wants to remain in motion, and this property of the object is called as inertia. And the definition says that the tendency of a body to resist a change in its acceleration. So if this was at rest, if it is moving, that means acceleration has taken place, but it does not want this to happen, and this is why we say it resists a change in its acceleration. Now why do we understand inertia? Because the first law of motion is actually related to inertia. Now this object over here is now at rest. Until when will it remain at rest? It will remain at rest as long as there is no external force acting on it. But as soon as we apply an external force in the form of an accelerator, we know it starts moving. That means it is set into motion only after the application of a force. And this force is an unbalanced force. Why do we say unbalanced force? I'll explain in a while. So from this example, what we understand is the object which is at rest continues to remain at rest. Now in space, what happens is the asteroids which are moving, they keep on moving on and on and on and on, because there is no external force there to stop it. That means the object which is in motion continues to remain in motion. Now let us join these two examples, let us merge these two examples and understand the statement of Newton's first law of motion. It says an object continues to remain in the state of rest or in the state of uniform motion along a straight line unless an external unbalanced force acts on it. Now why do we specify the word unbalanced? Let us take an example and try to understand. Here you can see we have two teams, and these two teams right now are applying equal force. That means this is a balanced force. What is a balanced force, or what are balanced forces? Those forces which are equal in magnitude but opposite in direction. So here you can see whenever there is an application of a balanced force, we can see there is no motion taking place. But we change the scenario. In this scenario, we know that this team is applying more force. Now since the force applied by this team is more, it is an unbalanced force, and here we can see motion takes place. That is why we need to specify the word unbalanced. Now what we understand from here is the object which is at rest wants to remain at rest. The object which is in motion wants to remain in motion. This is what is inertia, right? That means Newton's first law explains the phenomena of inertia, that is the inability of an object to change its state of motion on its own. And that is the reason the first law of motion is also called as law of inertia. So this was Newton's first law of motion.